Hey everyone, and welcome to this technical overview titled Deploying Containerized Applications, DO080. My name is Zach Gutterman. I am a curriculum architect for Red Hat Training. And in this technical overview, I will be introducing you to the what, how, and why of containers. I'll step you through how to create your own containers, how to create container images, and then later on in the course, we'll start talking about OpenShift and Kubernetes and how we can orchestrate and scale all of our applications. So let's jump right into it, and I'll give you a quick overview of container technology. So before we dig into containers, let's talk a little bit about where containers came from. So what were we doing 5, 10, or maybe even some of you are still doing now? How are we deploying our applications? Now, typically, applications are deployed on top of hardware, on top of an operating system, and usually using some sort of a virtual machine or something like that. Our applications, actually I want to go ahead and draw this for us. So let's say we've got our hardware here at the bottom, okay? This is our hardware. And now on top of our hardware, we've got our operating system. So this is what's running, what our applications are going to be running on top of. Okay, so on top of our operating system, we've got all of these libraries, and these are the libraries that are supporting our applications. And finally, all the way at the top, we have our applications. Okay, so let's say that this application right here, this one's a Python application, and this one's a Java application. Okay, so each of these apps, they're borrowing, they're using this library, the Python one's using this one, the Java ones are using this one, and maybe they even share some of the same libraries. Okay, so what are some of the struggles with this type of architecture? One of the big problems is that this Python and this Java application right here, these guys are closely coupled to the operating system. So if anything changes down at this layer here, at this operating system level, it's going to affect those applications. Okay, not only that, another issue is that if anything changes with these libraries, so let's say that there is an update to this library right here. Remember, this is a library that's shared by both of our applications. If there's any change to one of those libraries, we have to go through and test all of our applications again. Now, in this example, we only have 2 applications, but you can imagine that if we had 5, 6, 7, 8, 9, 10 applications deployed on here, any small change that we make to the operating system is going to require us to go through and test every single application. It's just not a very viable strategy for scaling out. It's not a good strategy for organizations that really want to grow. So, what did this lead to? It led to users needing a fast and lightweight way to spin up virtual machines, right? Where virtual machines are great because they're really portable, but they're still really heavy. They take a really long time for us to start up. They include a lot of things that we don't necessarily need, and they still have this problem where we're still going to be tied or too closely coupled for our application. So it would be great if we had a way to sort of isolate these virtual machines in a better way, and if they could be more lightweight so they could start up a lot faster. So containers were born. Okay, so what is a container? You've probably heard the term so many times, but maybe you haven't actually seen a definition of what a container is. So containers are a set of one or more processes that are isolated from the rest of the system. Now, I realize that's kind of an abstract definition, but what that really means is a container has a lot of the same benefits as a virtual machine, and it allows you in a very isolated way to deploy your applications. So when I say a process, that can be starting an application server, it can be starting a MySQL server. So when you think of process, you can really think of your applications. So again, a lot of the same benefits as a virtual machine, but they have a few benefits on top of a virtual machine. So one of those is having a low hardware footprint. So because of using these Linux things such as cgroups and namespaces, we're able to create a very isolated environment, and that's going to help us minimize how much CPU and memory is being used on the host machine. They're very quick to deploy, and they're very reusable. So because they're based on a blueprint known as container images, we can easily reuse them as many times as we want. We can share them. There's registries that we can use to upload them that are public. We can just go on and find our own container images and make as many containers as we want. Deployment times go from minutes, tens of minutes, to just a few seconds once you have those images available on your machine. Environment isolation is another important thing. So containers work in an entirely closed environment. So they can run on anywhere, they can run on your Mac. It really doesn't matter what the underlying operating system is, because a container is a self-contained environment that has its own operating system. Multiple environment deployment. So building on top of this environment isolation is that containers are highly portable. You can move them anywhere. You don't have to worry about, okay, this works in our development environment. Is it going to work in our staging environment? Is it going to work in production? You know that it's reliable because you're basing all of your containers on the same image. So you know that everything in that environment is going to be to your specification. Okay, so you saw my drawing earlier of a traditional OS here on our traditional deployment on the left, and then on the right we have what a container architecture would look like. So remember, again, we've got these two applications on the left here, and these applications are using a traditional architecture where they are borrowing their libraries from a host operating system. Now, these two applications, they are not truly isolated from each other, and that is because how closely coupled they are to each other inherently by using the same libraries on a host operating system. Again, if anything was to change with one of these libraries, we have no idea what the effects could be on app A or app B. Now contrast that with a container architecture. So a container architecture says, okay, let's change this whole paradigm, and we're just going to bundle all of the libraries that app A needs, and we're going to put it into its own isolated environment. And then we're going to do the exact same thing for app B. So yeah, there may be, maybe library A and library B. I mean, maybe there's some overlap there. Maybe we're doing a little bit of duplication. But what we're getting in return is we are getting complete isolation, so that any changes that we need to make in app A, if we have to update one of the libraries, we don't have to ever worry about how that's going to affect app B or app C or app D or app E. So it's really going to cut down on our need to test. Further, because of this, we are not needing to install an entire host operating system. So we are only using the container operating systems. We'll talk a lot more about what types of base images, as they're called, or base operating systems that we're using. But essentially, these operating systems are a lot more stripped down than the typical VM operating systems, which are fully fledged RHEL operating systems, things like that. We're just using a stripped down version of it, which is going to make it a lot more efficient. All right, so that concludes our overview of container technology, and join us in the next video and we'll start talking about container architecture.